Hello, everyone. This is part 3 of a chapter 13 lecture. In the previous session, we examined the concepts of average cost and the marginal cost. More specifically, now we know how to calculate average total cost, average fixed cost, average variable cost, and marginal cost. We also have a now better understanding of each of those cost concepts. In this session, we're going to further investigate average cost and the marginal cost, and we're going to learn how each cost changes as output grows. Simply put, as we increase the level of output, as we produce more and more output, what happens to each of those average cost and the marginal cost? That's the one of the primary topics of this session. Okay, so first we're gonna turn to our lecture note. Okay, here, example 1, I borrowed this example from your textbook. So it is a fairly large table, and the first column shows level of output. Here, the cups of coffee per hour. So the output increases from 0 to here 10. And the second column is a total cost. And the third and fourth columns are fixed cost and variable cost. So now we know that total cost is fixed cost plus variable cost. So we also know that fixed cost remains the same even when output is increasing. And we also know that variable cost increases as more output is produced. Okay. So now the remaining 4 columns of this table. Okay, the number 5 column is what? Average fixed cost. So we know average fixed cost is what? AFC is simply what? Fixed cost divided by quantity. And average variable cost is AVC is what? Simply you divide the variable cost by the quantity produced. And the average total cost is what? Simply total cost divided by quantity produced. And finally, marginal cost is simply what? The change in total cost divided by change in quantity. Okay, so that is a marginal cost. So first, we can confirm here in this table that fixed cost remains the same regardless of the level of output. So here, whether you produce a 0 output or you produce 4 units, fixed cost is exactly the same. Okay, but on the other hand, variable cost increases as more output is produced. As you can see here, as the output increases, as you produce and sell more and more cups of coffee, variable expenses increase. Okay, and another important information you need to remember here is what? Variable cost is 0 at the 0 output level. Okay, now first look at column number 5, average fixed cost. As we confirmed previously, average fixed cost is always declining as more output is produced. So if you look at column 5, then what? Average fixed cost is what? Never increasing as more output is produced. It only declines because fixed cost does not change. Yet more and more units are produced. So if you divide a fixed number by a greater and greater output, then the value will be smaller and smaller. Okay. Now look at number 6 column. Average variable cost. Well, average variable cost is variable cost divided by Q. So now VC, variable cost divided by Q. Now, numerator is variable cost, denominator is quantity produced. So as you produce more output, denominator Q increases. But we also know that variable cost also increases as you produce more output. So both numerator and denominator become bigger and bigger as you produce more output. Now, depending on which one grows faster, average variable cost may become smaller or greater. So let's see in this example. Average variable cost per unit is increasing here. As you produce more and more cups of coffee, average variable cost is what? Increasing from 30 cents to all the way up here, $1.20. Okay. This is a possible scenario, but this definitely is not a typical case. Okay. So don't ever think this is a general case. Okay. All right. It is possible, but it is not very common. Now, column number 7, average total cost. Okay, now we divide the total cost by the quantity. And here what happens? Average total cost is now what? As you produce more and more, then what? It is decreasing. The cost of the typical unit is actually falling as you produce what? Up to 6 cups of coffee. But when you produce more than 6 cups of coffee, then what? Average total cost. The cost of a typical unit starts rising again. Okay, so this is what so-called what we call what U-shaped. So U-shaped average total cost curve. So that means when you increase the output over the first few units, the cost of a typical unit, the average total cost is declining. Then beyond a certain output level, average total cost starts rising again. So that's why we say this is what U-shaped average total cost curve. Okay. Now, look at the marginal cost, the last column. Well, again, as you increase the output, in this example, the number of cups of coffee. So as you increase the output by 1 each time, okay, then the cost of producing additional cup of coffee, for example, here, from no output, now you produce the first cup of coffee. That coffee costs you what? 30 cents. Now, when you increase your output from 1 cup of coffee to 2 coffees, then what? Change in total cost is what? Change in total cost is what? 50 cents. So producing the last cup, the second cup of coffee is now what? Costing 50 cents. Now, if you increase total output from 2 to 3, then when you produced 2 cups of coffee, total cost was what? $30.80. Now, when you add 1 more cup of coffee, total cost is rising what to $4.50. So total cost increases by 70 cents. So in this particular example, whenever you produce one more cup of coffee, it costs you more and more. It costs you increasingly more. So that's why in column 8, marginal cost, whenever you add what? One more cup of coffee, then what? Total cost is rising what? A lot more. Total cost is increasing, but in an increasing manner. Okay. So again, is this always common? Not necessarily. Only in this example, if we calculate marginal cost, then what? Each additional cup of coffee is what? Costing you more and more. Okay. So now we're going to copy the information contained in this table into cost quantity space. That is on the next page. Okay. You will find exactly the same figure in your textbook. First, look at the average fixed cost. We confirmed just a minute ago that average fixed cost is always declining as more and more output is produced. So what do you see here? This average fixed cost curve is what? Almost like an L shape, and it never rises again. Okay, so it always what? Declines. Okay, now in the previous table, when we calculated the average variable cost was what? Also rising as more output is produced. So average variable cost curve is what? It has a positive slope. Okay. But average total cost, well, in the previous table, average total cost was what? First declining when you produce what? Up to 6 units. And then beyond that, average total cost starts rising again. So it has a U shape. So we can confirm that in this figure. Okay. So average total cost curve is now what? It has a declining segment until you produce what? 6 cups of coffee, and then it starts slightly what? Rising again. So it has a what? Kind of a U shape. And the marginal cost in the previous table, well, we learned that whenever an additional cup of coffee was produced, that additional cup of coffee cost what? Cost more and more in an increasing manner. Okay, so that's why again, marginal cost curve here is what? It has a what? It does not have any declining segment. It is always what? Increasing, so positively sloped. But once again, the same information can be presented in 2 ways. Either in a table form like this, or in a figure, using curves. Okay, but information contained in the table and in this figure is exactly the same. Okay, but keep in mind that the shape of each cost curve you see in this figure, okay, is not necessarily always true. Okay, but here, what's true here is what? Always true is what? Average fixed cost curve. Because you divide the same fixed cost by quantity, increasing quantity, so what? As output increases, can average fixed cost rise? Never. It only declines. Okay. Now, in the next example, we're going to look at more general cost of a production. Okay. So here, example 2. All right. So here we produce a certain product, a good, okay, from 0 to 10 units. Okay, now let's confirm. In the second column, okay, so this is the first column, the level of output. In the second column, fix the cost, whether you produce 0 output or 10 units, fixed cost remains the same. So we can confirm this. And variable cost, what do we know? It does take a lot of materials, time and money to produce a good. So the more of a good you produce, then what? The greater is what? Variable cost. Can we confirm that here? Yes. As the output grows from 0 to 10, variable cost is what? Also increasing. Now, total cost is what? Simply fixed cost plus variable cost. We can confirm that. If you add up fixed cost and variable cost at each output level, that's what? Exactly the total cost of production. Now, let's talk about a family of average cost. Average fixed cost is what? Let's say column number 5 is what? So average fixed cost is simply fixed cost divided by quantity. So you divide the same fixed cost by a greater and greater output. So what? Average fixed cost is always declining as more output is produced. So it can be easily confirmed. Now, average variable cost, that is a variable cost divided by Q. So as more output is produced, as your denominator Q increases, then what? The numerator variable cost also increases. Now, depending on which one grows faster, average variable cost may increase or decrease. So let's see here. When you produce what? 1 unit through 6 units, what happens? Average variable cost is what? Decreasing. Okay. However, beyond 6 units, then what? As you produce more output, then what? Average variable cost starts rising again. So we can confirm here, average variable cost is what? Average variable cost curve has a U shape. Now, column number 7, average total cost. This is what? Total cost divided by quantity. So now what do you see here? Well, as you increase output from 1 to 10, average total cost is what? It is falling. And then it starts rising again. So it also has U shape. Okay. And then finally, the last column, we're going to look at the marginal cost. So marginal cost is what? Simply change in total cost over change in Q. Or since the fixed cost does not change, if there's any change in total cost, then what? The cost change must be stemming from change in variable cost. So you can define marginal cost this way as well. Change in variable cost divided by change in Q. Okay, so here, let's examine what happens to marginal cost as output increases. So here, as output increases, as you produce more and more output, then what? Marginal cost is falling up to 4 units, and then beyond 4 units, then what? The cost of producing additional unit is what? Now increasing. So here, marginal cost also has what? U shape. Okay. So this is a lot more general case. Now we're gonna copy exactly the same information in the table onto cost quantity space. Okay. Now that is on the next page. Now, first confirm here that average fixed cost is what always declining as more output is produced. It never rises as output increases. Okay, so that's confirmed. Okay, so it is always declining as output increases. Okay, now let's look at average variable cost and average total cost. They both have what? Kind of a U shape, okay? That means both average total cost and average variable cost what? Are declining up to certain output level, and then beyond that, they start rising again. Okay, that's exactly what we confirmed in the previous table. And marginal cost as well has what? U shape. So marginal cost was first declining as you produce more output, then what? Beyond a certain output level, it starts rising again. So it has a somewhat U shape, okay? All right, so just remember that this is what? A lot more general than the example that we discussed earlier. Okay, so then here we're going to ask a very interesting question. Why is a typical average cost curve U-shaped? Now, in this example, in a more general case, ATC, average total cost, average variable cost, and marginal cost curves have a U shape. Okay, why? Okay, that's what this question is all about. Why is a typical marginal cost curve U-shaped? Okay, now to have a better understanding of this, so what? We're going to use a very simple example. Consider a simple production process that only requires a fixed capital investment. So here, fixed capital investment means just what? A fixed number of machines. So here we're going to assume that there are 3 machines, and it does cost $100 per machine per day. Okay. So we use 3 machines, and each machine costs $100 per day. And then we're going to assume that the only other input is what? Just labor. Well, in real life, we're going to have to use a lot of natural resources, but to make our analysis simple, we just assume that you use only 2 kinds of input. One is machine, the other is labor. Okay. So since you have 3 machines, okay, fix the number of machines, 3 machines, and each machine costs you $100 a day. So what's the fixed cost per day? That is what? 3 machines times $100 per day, so what? $300. And the cost of labor per worker per day is $100. So this is, we assume here, okay? So this is just an assumption, okay? So we assume the cost of a worker per day is what? $100, okay? So if you hire no workers, then what? No labor cost. Now, if you hire 1 worker a day, then what? Labor cost will be $100. If you hire 3 workers a day, then labor cost per day will be $300. Okay. Note that expenses on labor are the only variable cost. Okay, so we only use two inputs, machine and the labor, and the number of machines are fixed. Okay, unless you expand the size of your factory, other than that, you cannot change the number of machines, only 3 machines, but you can flexibly increase or decrease the number of workers. So labor expenses in this example are the only variable cost. So here, so we have 3 machines, and each machine costs you what? Okay, $100 a day, okay, per day. So each machine, $100 per day, and here, and the number of machines are fixed. So no matter what you do with the 3 machines, it costs you what? $300 a day. Now, depending on how much you produce, you may hire 1 worker or as many as what? 9 workers here. Okay, so the first column denoted by L, this is what? This is the number of workers you use per day. So look here, we assumed that labor expenses are the only variable cost. So if you hire no workers, then what? Variable cost is 0. If you hire 2 workers a day, then what? Variable cost per day will be $200. If you hire 8 workers, then what? Variable cost per day is what? $800. Okay. But fixed cost, the cost of machines, because since we only have what? 3 machines, and each machine costs you $100 a day. So what? Fixed cost per day is always what? $300. So fixed cost does not change. And then total cost is fixed cost plus variable cost. That is what? Total cost. All right. So now here, look at average total cost. Okay. So here what happens. If you look at average total cost, then what? Average total cost is falling as you hire more workers and produce more output. And the average total cost is at the bottom, the lowest, when you produce 115 units with 6 workers. But if you produce more than 115 units by hiring more workers, then what? Now, average total cost starts rising again. U shape, okay? And then marginal cost here, as you increase the output by hiring more and more workers, then what? The cost of producing 1 more unit, the cost of what? 1 additional unit, okay, producing 1 additional unit is now what? Falling. And then it starts rising again here. When does marginal cost start rising again? That's when you hire number 4 workers and produce 80 units. So why is that? Now remember here, we have a fixed number of machines, okay? Look here. So I want you to focus on the first 2 columns of this table. So you have 3 machines, but if you do not hire any worker, so when 3 machines are not combined with any labor, then what? Well, machines by themselves cannot produce any output. Okay, so without any workers, output is 0. Okay. Now, you hired only 1 worker. So that means 1 worker combined with the 3 machines. But 1 worker cannot operate 3 machines at the same time. Each worker, 1 worker can operate 1 machine at a time. So there are 3 machines, but you hired only 1 worker. Then at any moment, 2 machines are not in use. Okay, so you can produce, let's say, only 10 units. Okay, so 1 worker with 3 machines. So you produce only what? 10 units. So now you hire another worker. So you have a total of 2 workers. 2 workers with 3 machines. Now, of course, you have another helping hand, so you should be able to produce more, right? Yes. Output increases from 10 to 25. Now, here, output, you added 1 more worker, so now you have 2 workers. Then output actually what? Increased what? More than the what? Increased to more than 20. With the 2, when 2 workers are combined with the 3 machines, then what? Total output is what? 25. How is that possible? Well, it is possible. It's very likely. Why? When there is only 1 worker with the 3 machines, then what? Whenever this worker takes a short break, none of the machines in use. But when there are 2 workers, then what? Even when 1 worker is taking a break, still the other worker can produce output. So that means what? With the 3 machines, okay, if you have 2 workers, then what? These machines are better utilized than when you have only 1 worker. Now, if you hire 3 workers and produce even more output, so here, when you have 3 workers, when 3 workers are combined with 3 machines, then what? Output is increasing even faster. Output increased here what? First by 15, and then output now increased by what? 30 here. How is that possible? Look, now when you have 3 workers, then even when 1 worker is taking break, still 2 other workers are producing out. Even when 2 workers are taking break, still 1 worker can produce out. Okay, so 3 machines are what? Probably the best utilized when 3 machines are combined with the 3 workers. Okay, now one more. Okay, so you still need to produce more output. So you added the number 4 worker. So now with the number 4 workers, what happens? 4 workers with the 3 machines. So total output is now what? 80. Okay. But now watch it very carefully. When you add another worker, so let me write down here, it works better. When 4 workers are combined with the 3 machines, total output increases to what? 80. The increase in output, additional output you get from adding another worker, number 4 worker is now what? Total output is still increasing from 55 to 80, but this time it increased what? Increased only by 25. Look, when you added the number 3 worker, output increased from 25 to 55. Additional output you get is what? 30. But when you add a number 4 worker, output is increasing from 55 to 80, but additional output you get, an additional worker is what? Only 25. Why is that? Okay, so let me save some space here. So let me use the erase, okay. Okay, I needed save some space, and this one as well. Okay. So let me explain to you why. When you add a number 4 worker, now there are only 3 machines. It is impossible that 4 workers are working with the machine at the same time. Okay, so when you have 4 workers, then what? At any moment, one worker is what? Waiting for his turn or her turn until someone takes break, because there are only 3 machines. So with the 3 machines, when there are 4 workers, then what? Even 3 workers are taking a break, still what? Number 4 worker can use what? A machine, so what? Output will increase. But one of the 4 workers will have to wait for his or her turn because there are only 3 machines. Now, it gets worse and worse if you hire more than 4 workers. Now, if you hire 5 workers, okay, so here you hire 5 workers, and so 5 workers are combined with what? 3 machines. Then total output is still increasing to 100. Okay, so total output increases to 100. But this time, even when you add what? Another worker, number 5 worker, total output increases, but the increase in output is what? Smaller than before. This time, output increases only by what? 20. It's not because number 5 worker is what? Slacking or lazy. It's simply because you just combine greater and greater number of workers with a fixed number of machines. So when there are 5 workers, then what? At any moment, you will see 2 workers not working because there are only 3 machines. Okay, so with the 5 workers, at any moment, 2 workers are waiting in line. Okay, so whenever somebody is taking a break, okay, these are what the extra workers can use the machine. So total output will increase, but their contribution will become smaller and smaller as more and more workers are added. Okay. The main cause of this problem is what? You can increase the number of workers, but the number of machines are fixed. Okay. So when you hire up to 3 workers, then what? Output increases, and the contribution to the output made by each additional worker is what? Increasing. Okay, so let me write this down. So here, until you hire 3 workers, output increases, and additional output you get from an additional worker. Whenever you add another worker, the additional output you get is what? Also increasing. Here, that is measured here along this column. Additional output you get. So from no workers to 1 worker, that additional worker made a contribution of what? 10 units. Now, when you add 1 more worker, so when you increase the number of workers from 1 to 2, by adding a second worker, output increased by 15. When you added the number 3 worker, total output increased what? From 25 to 55. So additional output you get from an additional worker is what? Even greater, 30. However, if you hire more than 3 workers, now what happens? Because the number of machines are fixed, one worker, number 4 worker, or whoever it is, only what? 3 workers can use 3 machines at the same time. So always what? One worker has to wait what? His or her turn. So that what additional worker can contribute to the output. Why? Because whenever somebody's taking a break, he or she can use a machine. But unless somebody's taking a break, one of the 4 workers has to wait. And it gets worse and worse if you hire more and more workers. For example, if you hired what? 8 workers, okay? Then what? At any moment, only 3 workers can use what? 3 machines. That means what? 5 workers are waiting in line. So that's why they can contribute, but their opportunity to make a contribution will be limited because there are only 3 machines. Okay. Now, what happens to the cost? When you hire more and more workers, okay, whether they are actually what? Using a machine and producing output or not, they all cost you what? The same. Each worker will cost you $100 a day. So see here, what happens to number 4 workers, okay? So this number 4 worker, okay? So you have 3 machines, now you have a total of 4 workers. And this last hired worker has to wait for his turn. So unless somebody's taking a break, number 4 worker cannot have access to machine. So even though he is waiting for his turn, doing nothing, yet you have to pay him or pay her $100 a day, right? So even though they are not working because the number of machines are fixed, even though they cannot use a machine, just waiting in line, yet you have to pay him or her $100 a day. So it gets worse and worse. So suppose you have 9 workers total. At any moment, only 3 of 9 workers will be able to produce output because there are only 3 machines. Then what about 6 other workers? They are waiting for their turns. Yet each of them is what? Costing you $100 a day. So that's what? Inefficiency. So that's why when you use what? Up to 3 workers, okay, then what? 3 machines are better utilized. And so what? Output is not only increasing, but also increasing faster. Okay, so additional output you get from additional worker is what? Increasing. Total output is increasing, and the additional output you get, change in quantity is also increasing. But after that, what happens? What happens? After that, if you hire more than 4 workers, okay, if you hire more than 4 workers, then what? Output is still increasing because when somebody's taking a break, they can continue to produce output, but their contribution is limited, their access to a machine is limited, yet each of them will cost you $100. Okay, so whenever you, to produce more output, you hire 1 more worker, variable cost is what? Continue to always what? $100. So what do we know? Marginal cost is what? Change in total cost over change in Q, or change in variable cost over change in Q. So here, whenever you produce more output by hiring 1 more worker each time, variable cost is what? Change in variable cost is $100. But change in output is what? First time increasing faster, and then what? Increasing smaller and by smaller and smaller amount. So that's why marginal cost is what? Marginal cost is So here, whenever you hire one more worker by spending another $100, additional output you get is what? Increasing. Okay, so each additional unit costs you less and less. But once you have what? More than 3 workers, then what? One worker is waiting in line all the time. Okay, at any moment, only 3 over 4 workers are working and the one is waiting in line. Yet the person will cost you exactly the same as what? The other workers, $100. So now you divide the change in variable cost by quantity, then what? Marginal cost starts increasing. Because of that, now what? Each additional unit, to produce each additional unit costs you more and more because the number of machines are fixed. So what? Eventually, the cost of producing additional unit is what? Increasing. So what? Eventually what? Average cost will also increase. Okay. Now, here we have a very interesting phenomenon here. That's what we call diminishing marginal product. Diminishing marginal product means what? By hiring one more worker, you get additional output. But that additional output, marginal product, is now what? Falling beyond a certain point. Here, because we only have 3 machines, if you have more than 3 workers, then what? At any moment, one worker, one of the 3 workers will, one of the 4 workers will be what? Waiting in line. Yet the person, whoever waits in line, that person will cost you what? As much as other workers, $100. So here, when you have what? 3 workers combined with the 3 machines, then what? Up to 3 workers, then what? Each time you add another worker, additional output you get is what? Increasing. Okay, from 0 workers to 1 worker, when you added what? 1 worker, that worker contributed to output. How much? By 10. When you increase the number of workers from 1 to 2, when you add a second worker, the addition of what? A second worker contributed to the output by how much? 15. When you increase the number of workers from 2 to 3, the additional output you get from an additional worker is now what? 30. It gets bigger. But when you have the number of workers 4 or more, than now what? They still contribute, but additional output you get from hiring an additional worker is starting falling. Why? It's not because they are lacking, they are slacking, they are lazy. It's simply because number of workers increasing, but number of machines are fixed. They just cannot have enough access to a machine. That's why. Yet each of them will cost you what? $100 a day. Okay, so that's why total cost is increasing each time by $100 as you add another worker. Yet output is growing, but additional output you get is what? Smaller and smaller. So that's why marginal cost is falling, and then what? Beyond the number 3 workers, then what? Marginal cost is what? Rising. Because even though they are waiting in line, you keep paying them $100 a day, but they cannot really add much to the output because the number of machines are fixed at the 3. Okay. So when additional output you get from hiring an additional worker starts falling, then what? We say there is what? Diminishing marginal product. So changing Q, look at changing Q. Here, as you hire more and more workers, what? Up to 3, marginal product, additional output you get is increasing. But beyond that, then now what? Additional output you get becomes what? Smaller and smaller. That's what? Diminishing marginal product. So here, when does diminishing marginal product occur? When does it take place? The answer is what? When you hire 4 or more workers. And of course, the first time we observe diminishing marginal product is what? When is the first time you observe the diminishing marginal product? It happens the first time what? When you hire what? 4 workers. Okay. And so it is not just a coincidence. When diminishing marginal product means what? You just spend the same amount of money and add another worker, but extra output you get becomes just smaller. That means what? Aha, beyond that point, to produce an additional output unit, it costs you more and more. So what? So when diminishing marginal product occurs here, when you have 4 workers, that's exactly when what? Marginal cost starts rising. Okay, so the lesson here is what? Marginal cost starts rising when diminishing marginal product occurs first time. Okay, that's exactly when marginal cost starts rising. Okay, all right. So why average variable cost, the average total cost, marginal cost eventually starts rising as you produce more output? It's mainly because the number of machines are fixed or the size of factory is fixed, but you just keep adding more workers to produce more output. So what? Workers hired later will not be able to contribute to an equal amount to the output. Why? Because the number of a machine is fixed. Okay, so when you keep adding more and more workers, additional output you get from an additional worker, that's marginal product. Okay, and then when does marginal product start falling? That's what? When you have too many workers relative to the number of machines. Yet each additionally hired worker will cost you the same amount, yet additional output you get is smaller and smaller. That's why marginal cost, the cost of what? Additional unit is what? Rising. So marginal cost starts rising when diminishing marginal product occurs first time. Okay, all right. Now, next topic is the relationship between marginal cost and average total cost. Well, there is a very interesting relationship between marginal cost and average total cost. Okay. Now, before we introduce the conclusion, we're going to use a very simple example. So the relationship is exactly the same. You have completed 2 exams, and your exam scores are 80 and 90. Okay. So if you score 90 on the next exam, what's going to happen to your average score? So far, you have completed the 2 exams, 80 and 90. So what's your current average? So average score so far is 1. You add them up and divide it by the number of exams you completed, so 2. So 170 divided by 2 is what? 85. So that's your average score. Okay. Average score. So average means what? At this point, you produced a certain amount, and then you divide the total cost by the quantity produced. That's your average. And then now, what will happen to your average score, okay, if you scored 90 on the next exam? Okay, if you, so your current average is what? 85. So if you do better on the next exam, if you do on the next exam better than your current average, what's going to happen to your average? Your average will rise, right? Here, so 80 plus 90 plus, if you score another 90, okay, then let's recalculate average, okay? So that's going to be what? 180 plus 80 is what? 260. So 260 divided by 3 is 86.67. So previously your average was what? 85. Now, after 3 exams, if you score 90 on the last exam, then what? Your average will go up to what? 86.67. Why? Because your marginal average means what? At this point, what you have gotten so far. Marginal means what? When you do what? Marginal cost is what? When you produce one more unit. Or in this context, when you take one more exam, what's the score? So if your marginal attempt, when you take one more exam, on that last exam, if you score better than the previous average score, then what? Your average will go up. Think of what? A Major League Baseball player. His batting average so far is what? 300. Okay, that's the average, batting average. Now, tonight, he's going to play another game. So one more game. If he hits tonight 400, then what's going to happen to his batting average? His batting average will go up, right? Because his when he did one more game, he plays one more game, and on that game he did better than previous average. Then what? Average will increase. So here, what do we know? Whenever marginal is greater than average, whether it's the exam score or it is a cost of production, it doesn't matter. If a marginal is better than average, then what? Average increases. Okay. Now, so you scored here 80 and 90 on the first 2 exams. So what? Your current average is what? 85. Now, you take one more test, exam 3, and on that exam you scored 80. Now what happens? Then 80 plus 90 plus again 80. And now you have 3 exams. So 250 divided by 3. Okay. So 250 divided by 3 is 83.33. So now what? When you score only 80 on the exam 3, then what? Now your average goes down. It's like what? A Major League Baseball player, before entering tonight's game, his batting average is 300. And tonight, he hits only 100. Then his average will be what? His batting average will go down, just like that. So here, if marginal, okay, one more game, okay, one more exam, your performance on one more exam, one more game is what? Worse than, smaller than your previous average, then what happens? Average decreases. Okay. And finally, what if you score 85 on the next exam? So previously, what? You scored 80 and the 90, and the average was what? 85. Now you take one more exam, exam 3, and on that exam you score 85. You divide it, then what? Your class average is what? Exactly the same. What it means is, if you take one more test or you play one more game, and on that last exam, if your marginal performance is the same as your previous average, then what? Average does not change. That's the relationship between marginal and average. This relationship is still holding whether it is a test score or cost of production. Okay? So that's why if you look at the graph, okay, let me go back to our previous graph here. What do you see here? Okay. So here, marginal cost curve. That means what? You take one more exam or you produce one more unit. Okay, that's a cost. All right. And then average. So here, what do you see here? Let's compare average total cost and the marginal cost. See here, these two are the same. At this point, marginal cost is the same as average total cost. But before this, what happens? At any output before this, smaller than this output, then what? Marginal cost curve is what? Positioned below average total cost curve. So let me use a dotted line, okay? So on this side now, average total cost curve is what? Average total cost curve is just positioned above marginal cost. So average total cost is what? Greater than marginal cost. So your additional performance, additional test score, when you produce one more unit, when you produce one more unit, that additional cost is smaller than previous average, then what? We said the average is falling. That's why average is falling. But on the other side of this dotted line, now marginal cost is what? Positioned above average total cost curve. So here, now what happens? Is greater than average. In other words, you play one more game, take another exam, and you produce one more unit, and then cost or test score is what? Greater than previous average, then what? What do we know? Average score is what? Rising. So this is now what? Rising here. Okay. So if we summarize, if at any output, if marginal cost is smaller than average total cost, then what? ATC is falling, decreasing as more is produced. So here, as long as what? Marginal cost curve is what? Positioned below average total cost curve, then what? As you produce more output, average total cost is what? Falling. However, if marginal cost is greater than average total cost curve, on the other side of this dotted line, okay? Marginal cost is greater than average total cost, then what? ATC is rising as more output is produced. So whenever MC curve is positioned above ATC, then what? As you produce more output, average total cost starts rising. Okay, so that's the relationship. Now we have one more topic left here. So that is cost in the short run and in the long run. So far, we assumed that what? Machine is fixed, or the size of a factory is fixed. The only input that you can flexibly increase or decrease was what? Like labor. But in the long run, over what? Extended time period, you can easily what? Expand the size of factory. You can easily what? When you build a bigger factory, then what? Of course, you can have what? More machines installed. Okay. So here, in this final section, we're going to talk about cost in the long run. Okay. So we're going to learn 3 different terms here. Economies of scale first. So economies means what? In economics, whenever we say there are economies of something, that means what? There are some savings. Okay. So economies of scale means what? As you scale up, the operation, there are cost savings. Okay, that's exactly what we mean by economies of scale. Okay, so there are cost savings. So there are some cost savings. Okay, so in other words, as you produce output on a larger scale, okay, or as you produce the output out of what? A larger factory, then what? There are cost savings. So here, what kind of a cost are we talking about here? Specifically, we are talking about what? Here, what we mean by cost is what? Average cost. Okay. So simply put, as you produce what? A product on a larger scale, then what? The typical unit costs you what? Less and less. So simply put, as you operate your business on a larger scale, then what? You can produce typical unit what? At the lower cost. That's economies of scale. Economies means what? Here, savings. Okay. So savings. Okay. And the scale means what? The size of a factory, for example. So what it simply means is what? The size of a factory is translated into cost savings. Okay. Cost savings. Okay, here, cost savings. Okay. So, simply put, within an industry, a company with a bigger factory, a larger company does have a cost advantage over a small company. Okay. In other words, through mass production, you can achieve a cost savings, or through mass production, you can produce a typical unit at the lower cost. If that happens, we say there is just the economy of scale. So let me give you a quick example. Suppose a small firm, okay, a larger firm here. Suppose here a small firm only produces 100 units, and when it does so, total cost is what? $10,000. Okay, so average total cost here is what? $10,000 divided by 100 units, so it is what? 100 units. So each unit, typical unit, costs $100. But a larger firm, it is producing 200 units, and yet somehow total cost is what? Less than $20,000. So let's say total cost is less than $20,000. So let's say just $19,000. How is that possible? Well, because this company is producing what? A lot more, twice as much output as what? A small firm. So when this company buys a lot of supplies, they may be able to enjoy what some discount, for example. Okay, so here now you calculate the average total cost of what 19,000 divided by 200 units. So what this is what only the $95. Okay, so let me double check. Yes. So each unit costs what? $95. So see here, a firm that produces more output has a cost advantage. So what? They can produce typical unit what? At $95, $5 less than what? Small firm. When this happens, we say there exists economy of scale. What it means is simply what? The larger is what? The better. Means that the larger, the lower the average cost. Okay. And the size of a factory is translated into cost savings. Okay. So now, again, graphically, what does that mean? That means as a firm size grows, okay, and here average total cost here, then what? As they produce more and more output, then what? As the size grows, then what? Firm size grows, then what? Average total cost is what? Smaller and smaller. Okay, so simply there is a declining. Let me rewrite. There is a declining segment. Okay, so there is a declining segment on average cost curve. Okay, so that is what, as a firm size grows, then what? Per unit cost is what? Declining. Now, this economy of scale means what? Somehow the as firm size grows, then somehow each unit is costing you more. So, for example, again, a small firm, a large firm. So, for example, small firms producing only 100 and the total cost is what? 10,000. So, average total cost is 10,000 divided by 100. So, typical unit costs you 100. But a larger firm, it is producing twice as much output, 200, and yet total cost is what? Let's say $21,000. So here, average total cost is what? 21,000 divided by 200. So what do you get? It's $105. Okay. So now typical unit costs you what? $105, $5 more than at the small firm. So why does this happen? Maybe as a firm size grows, maybe there could be some poor the coordination, okay, and poor communication, or the poor monitoring, okay, of workers. So now what? All those the sources of inefficiency is what? Adding up, and so on. And actually what? The cost is rising because you cannot monitor a large number of workers, so some are slacking, okay? And the poor coordination means what? Some wasted supplies, so they add up, and actually what? Average cost is rising. So that means that graphically, as a scale grows, size grows, then what happens? Actually what? Average cost curve is rising here. Okay, so a rising segment on average cost curve. Okay. Now, finally here, constant return to scale. That means what? So here it means what it means what? The size of a factory is not translated into any cost advantage or disadvantage. So that means what? Average total cost remains the same regardless of what? Of the size of a factory. So here, again, a small firm, let's say, produce 100 units, total cost is $10,000. So average total cost is $100. And now a larger firm produces 200 units, total cost is what? Also $20,000. So average total cost is exactly $100. So what do you see? As output doubles, total cost exactly doubles. So average total cost remains the same. So that means as the size grows, average total cost is what? No matter how many units you produce, average cost curve is what? Flat, remains the same. Now, once again, in economies of scale, what happens? As the output doubles, for example, here, total cost less than doubles. So that's why the typical unit costs you less and less. In this economies of scale, as the output doubles, total cost more than doubles. So what? Average cost is what? Increasing. And in constant return to scale, as the output doubles, total cost exactly doubles. So there's no change in average total cost. Now here, among these three different scenarios, what we are really interested in is what? Economies of scale. Okay, by operating a larger scale, we can achieve some cost savings. We can produce each unit at the lower average cost. Okay, now let me tell you one interesting story. Okay, more than 200 years ago, Adam Smith, he's called what referred to as the father of modern economics. So he wrote a book, very famous book, titled The Wealth of a Nation. And in his book, actually, he talks a lot about this what? Economies of scale. Okay, because when firms are operating on a larger scale, then it allows their workers to specialize in what? The specific production process. So he used an example of what? A pin factory. A pin factory. So suppose you have the, just a second, you have 5 workers, okay? So if you have 5 workers, then what? Okay, for example, first worker does only one particular thing. That is what? Draws a wire, okay? And the second worker only the what? The straighten, okay? So wire, okay? And the third worker now cuts the what? The wire, okay, in certain lengths. And the number 4 worker, all he or she does is now what? The sharpens the wire, okay? And then finally, number 5 worker The only thing he or she does is what? Make a head. So a pin is the production of a pin is completed. So when each worker is just specializing in a particular production process, then what? They will make less mistake, and what? Their work will become more and more efficient. That means they can produce more in any given amount of time. But now, these 5 different production process, if we assume these 5 different production process are completed by one worker, the same worker, then one worker has to draw wire, straighten wire, cut wire, sharpens wire, and make a head. Probably what? It'll take a lot more time. Okay. So this economy of scale is what? It is achieved through kind of a specialization. Okay. And as we say, the practice makes perfect. So through specialization, okay, we can produce more output, okay, for a given amount of time and money. That's why typical unit will cost you less and less. Okay. So Adam Smith, example of a pin factory is all about what? Economies of scale. Okay. On a larger scale, as you produce a larger quantity, so what? I mean, it is more suitable for specialization, and you can produce more output at a lower cost, lower unit cost. So here, now this figure actually what combined all 3 different features. So if average cost per unit cost is what? Curve has a declining segment, then what? As you produce more output, actually what? Average cost is what? Per unit cost is falling, so the what? Economy of scale. Now, here, between these 2 quantities, over this interval, between Q1 and Q2, whether you produce less or more, there's no change in average cost. So what? We say there are the economies, constant return scale. Now, beyond the Q2 here, as you produce more output, typical unit starts costing you more, rising segment. So when that happens, we say there is just diseconomies of scale. So between 0 and Q1, we have economies of scale. Between Q1 and Q2, constant return scale. And any output beyond the let me see. So at any output above Q2, so more than Q2, now we have what? Actually, diseconomies of scale. Actually, typical unit starts costing you more and more, okay? All right, this will conclude our lecture of chapter 13. Each session has been pretty long, and I really appreciate your patience. And I will see you next time with another chapter. Thank you.